Alright, this video we're going to look at MacLaurin series. We're going to take functions and we're going to rewrite them as a MacLaurin series. So I've got a video on Taylor series. So this is going to be similar to what we did in the Taylor series. Well, what a MacLaurin series is, it's a Taylor series, but A is equal to 0. Okay? That's what a MacLaurin series is. So if you watch my Taylor series video, one problem we had A was equal to 1 and another problem A was equal to 4. Well, here we're going to write an expansion for a MacLaurin series, and so A will be 0, and this is what we'll use to expand it. And also this continues on, so the next term would just be f triple prime of a times x minus a cubed over 3 factorial plus, and then we'd go on to the fourth derivative and so on. So let's go ahead and take a look at an example. Alright, they want us to find the first 4 terms of the MacLaurin series expansion of f of x equals 2 over 2 minus x. Alright, so finding the first 4 terms, so that means we're going to have to find all the way down to the third derivative. Alright, so let's go ahead and write down f of x is equal to 2 over 2 minus x. Okay, now we need to take the derivative. Well, to take the derivative, we can take f of x. Let's just come over here on the side and do it. We can take f of x and we can rewrite it as 2 times 2 minus x to the negative 1. Okay, bring this whole term up and see that would be raised to the first power, and then when we bring it up it would change it to the negative 1. Okay. Alright, so the first derivative, I would bring the negative 1 down, so that's negative 2 times 2 minus x, subtract 1, times the derivative of what's inside the parentheses, that's negative 1. So f prime of x would be 2 times 2 minus x to the negative 2. And so the first derivative would be 2 over 2 minus x squared. I'm going to move this back down. Okay, now let's find the second derivative. Alright, so the second derivative, I would bring the negative 2 down, so that's negative 4 times 2 minus x, okay, to the negative 3 times the derivative of what's in here, which would be negative 1. Alright, so the second derivative would be 4 times 2 minus x to the negative 3. So the second derivative would be 4 over 2 minus x cubed. And then I'm not going to go through finding the third derivative. You'll do it similar to the way we found the first and second. Just someone do this just to save time. And so the third derivative would be 12 over 2 minus x to the fourth. Okay. Alright, so let me get rid of this. Alright, so what we have to do now is evaluate each of these at 0. Because remember, a McClaurin series, it's when a is equal to 0. Alright, so we have f of 0 is equal to, that's going to be 2 over 2 minus 0, which is 1. F prime of 0 would be 2 over 2 minus 0 squared, so that would be 2 over 4, which would be 1/2. F double prime of 0 would be 4 over 2 minus 0 cubed, which 2 cubed would be 8. 4 over 8 would give us 1/2. And f triple prime of 0 would be 4 over 2 minus 0 to the 4th. Alright, so this would be 2 to the 4th, which is 16, and 4 over, I'm sorry, that's not a 4, is it? I think I was looking at this one up here. That would be 12. And so 12 over 16, that would be 3/4. Alright, so we have f of x is equal to f of a, or in this case f of 0, because that's what we're using for a. So that would be 1 plus f prime of 0, 1/2, times, okay, so remember this is times x minus a. And remember, for a McClaurin series, a is 0. So x minus 0 would just give us x. Okay, so that would just be x. Here we would just get x squared, and plugging in 0 here, that would just give us x cubed. Okay. Alright, so that would be times x plus 1/4 times, now this would be what? X squared over 2 factorial, okay, plus, and then this would be what? 3/4 times x cubed over 3 factorial plus dot dot dot. So we have 2 over 2 minus x is equal to 1 plus 1/2 x plus, and then this would be what? 1/8 x squared plus, and then remember 3 factorial is equal to 3 times 2 times 1, and you can see those 3's would cancel, and so I would be left with 1/8 x cubed plus dot dot dot. Alright, and so this would be the Maclaurin expansion for 2 over 2 minus x. Alright, let's take a look at one more. Alright, so looking at this, I notice I made a mistake. Okay, you see here, this would be f of 0, this would be f prime of 0, and this would be f double prime of 0. And for some reason, I put 1/4 instead of 1/2. So we'll change this to 1/2. So that's going to make this term 1/4. Sorry about that. Alright, let's look at the second example. Find the first 3 non-zero terms of the McClaurin series expansion of f of x equals sine to the 2x. Alright, so, well, let's see how many derivatives we have to take, because if we evaluate the derivative at 0 and we end up with 0, that's not going to count as a term. We need the first 3 non-zero terms. Alright, so we have f of x is equal to sine 2x. Alright, so let's come over here to the side. I've got f of x equals sine 2x. So f prime of x, well, the derivative of sine is cosine, so that's cosine 2x. And then remember, we have to multiply by the derivative of what we're taking the sine of, so that would be times 2. And f double prime of x would be, well, that's 2, and then the derivative of cosine is negative sine 2x times the derivative of what we're taking the cosine of, so that would be times 2. So f double prime of x would be negative 4 sine 2x. Alright, so I've got the first derivative is 2 cosine 2x. The second derivative is negative 4 sine 2x. Okay, so let me get rid of this, and you see how to take the derivatives. So I'm just going to go ahead and write down the next derivatives. Okay, you should know how to do that. Alright, so kind of what the question is how many derivatives are we going to need to take? Well, we know that we're evaluating each one of them at 0. So when we plug 0 in here for x, well, that's going to be the sine of 0, and the sine of 0 is 0. Okay, so that's not going to be that's not one of the terms. Well, if we plug 0 in here, that's going to be the cosine of 0, and cosine of 0 is 1, and 1 times 2 is 2. Okay, so there's a term. Well, once again, we're back to sine, and you can see these derivatives are going to alternate between sine and cosine. Okay, so right now I have this term, that's 1. Okay, this is not a non-zero term, so anytime I have sine, that's going to give me a 0. Okay, so that's going to give me an idea of what I need to do. So I've got f triple prime of x is negative 8 cosine 2x, and we know that cosine of 0 is 1, so we know this will be a term also. And then I have the fourth derivative. Well, the fourth derivative is 16 times sine 2x, so we know that's going to give us 0 when we evaluate. And I've got two terms, so I'm going to need to take one more derivative. Alright, so now let's take the fifth derivative, and that is going to give me 32 cosine 2x. Alright, so there's my third term. Alright, so now I know that when I evaluate this at 0, I'm going to get 0 as an answer. When I evaluate this one at 0, I'll get 0. And when I evaluate this one at 0, I'll get 0. Okay, so now let's look at this. We have f prime of 0 is 2 times cosine of 2 times 0, which is cosine of 0 is 1, so that's going to give me 2. F triple prime of 0 is negative 8 times cosine of 2 times 0, which that's going to give me negative 8. And then the fifth derivative evaluated at 0 is 32 times cosine of 2 times 0, which this is going to give me 32. So I have my values there. So now I have f of x is equal to, well, let me bring this down a little bit. It's f of x evaluated at 0, so f of 0, which that's 0, plus, and then this term, 2 times, now remember, it's x minus 0, but that's just going to give us x. So that's 2x plus, and then f double prime is 0, plus, okay, that's going to be negative 8, okay, and remember this is f of 0, this is f prime of 0 times x minus, so remember this term is x minus 0, and then this one, remember the coefficient's 0, and then this would be x minus 0 squared. Okay, so that means, and of course this would be over 2 factorial. I didn't write that because it's just all multiplied to 0. Alright, so this term is going to be negative 8 times x minus 0, which is just x, and that's cubed over 3 factorial. Okay, plus, now the fourth derivative, well, that was 0, and remember this would be x minus 0 to the fourth over 4 factorial, but since that's multiplied by 0, it's just going to be 0. Okay, plus, and now the 32, the fifth derivative evaluated at 0, times x minus 0 to the fifth, which is just x to the fifth, over 5 factorial. Alright, so we need to clean this up a little bit. So I have the sine of 2x is equal to 2x minus 4/3 x cubed, because this is what? 3 times 2 times 1, and the 2 and the 8 cancel. Okay, and then there's a 0, plus, and then 32 over 5 factorial, that's going to be 4 over 15 x to the fifth minus dot dot dot, and there's our first 3 terms. So this would be our solution. Alright, so I hope this video helped. Sorry about the dog barking if you heard him. And if you like the videos, you can watch my other ones and you can subscribe. Alright.